Section 5.1 is called the polygon angle sum theorems. And we're going to have a quiz in this chapter after section 5.3. Right, so all a polygon is it's a closed figure in a plane that is a union of line segments. It's a many-sided figure. Okay, and then we're going to talk about specific types of polygons. So if your polygon has four sides, it has a special name. It's called a quadrilateral. And you can have all different types of quadrilaterals. You can just have a generic quadrilateral, which is just a figure with four sides. You can have a square, which is going to end up having right angles and all congruent sides. You can have a rectangle, a parallelogram, a rhombus, and a diamond parallelogram. Okay, you can also have something called a pentagon. A pentagon would be a five-sided figure. A hexagon is a six-sided figure. An octagon is an eight-sided figure, and a decagon is a 10-sided figure. And you can see the figures over on the right each have their name inside of it, so you can kind of get a feel for what they look like. A regular polygon is a polygon that is both equiangular and equilateral. So equiangular, all equal sides. Equilateral, all equal angles. So here's the important thing for all of this. The polygon angle sum theorem, what that says is that the sum of the measure of the interior angles of any polygon with n sides is 180 times n minus 2. Okay, so the one that we've been talking about in general so far has been a triangle. So a triangle has three sides. So if you stuck in 3 for n, you would have 180 times 3 minus 2, or 180 times 1, which is just 180. So that's how the triangle has 180 degrees. And in this section, you're going to see other figures that have more than 180 degrees in it now. So to find the sum of the measure of angles of any polygon, you're going to use that little formula, 180 times n minus 2, where n is your number of sides. Hey, if you wanted to know the measure of one of the interior angles, you're going to take that 180 times n minus 2 and divide it by the number of sides, and that will give you the measure of one interior angle. So again, it'll be helpful if you have a calculator just to do these calculations. Who wants to do this by hand? So we want to find the sum of the interior angles of a pentagon. So again, the formula is 180 times n minus 2. Pentagon means 5, so that means that n is going to be 5. So you're going to have 180 times 5 minus 2, or that's the same thing as 180 times 3, which is 540. So if you take all the interior angles of a pentagon and add them together, it's going to add up to 540 degrees. A 12-sided figure doesn't have a special name like a pentagon does, but again, we're going to use that 180 times n minus 2, and this time n is 12, so I'm going to have 180 times 12 minus 2, or 180 times 10, which should give me an answer of 1,800. Again, so if you add up all the interior angles, all 12 of them added together would give you 1,800. So now for number 2, we want to find the measure of one interior angle of a regular decagon. So again, what I'm going to do is I'm going to find it's the sum first of the interior angles. So I'm going to do 180 times n minus 2, and then I'm going to divide that by the number of sides that it has. Again, a regular decagon means all equal sides, all equal angles. A decagon is a 10-sided figure, so all I'm going to do is take out my ends and plug in 10. So I'm going to have 180 times 10 minus 2, all divided by 10. Or 180 on the top, 10 minus 2 is 8, divided by 10. I'll keep going. I'll simplify the top. 180 times 8 is 1440. And I need to divide that by 10. And when I do that, I should get an answer of 144. So the measure of one interior angle of a regular decagon is 144 degrees. Okay, for number 3, we want to find the measure of the missing angle. Okay, and the first question that we're going to ask ourselves is, what is the first thing that we need to know to answer this question? Okay, the first thing that I'd like to know, everything that we've been talking about, every problem so far, deals with the number of sides. So all I'm going to do is literally count the number of sides. So there's 1, 2, 3, 4, 5. I have 6 sides. All right, so the next thing I'm going to do is I'm going to find out what the sum of all of the angles should be if I have a 6-sided figure. So I have 180 times n minus 2, or 180 times 6 minus 2. 6 minus 2 is 4, so 180 times 4 is 720. So that means if I take all 6 angles, 1, 2, 3, 4, 5, 6, and add them together, the sum has to be 720. So I'm going to take, and again, just don't forget, each one of these with the box in it means that it's 90. You can't just leave them out. So let's start. So I'm going to start with x, and I'll work my way counterclockwise around. So I'm going to have x plus 130 plus 90 plus 140 plus 150 plus 90, and that has to equal that 720. So adding up all those numbers on that left-hand side, you should get an answer of 600. So you're going to have x plus 600 equals 720. And subtract that 600 from both sides. And your last remaining angle is going to be 120 degrees. All right, so now we're going to switch from the interior angles to the exterior angles. Okay, so the polygon exterior angle sum theorem, the sum of the degree measures of the exterior angles of any polygon, doesn't matter how many sides it is. If you take all the exterior angles, they're going to add up to 360. So again, you can see this picture over here. I have 1, 2, 3, 4, 5 sides, which means there's 1, 2, 3, 4, 5 exterior angles. Take them all together, add them up. It's going to equal 360. Okay, so if I want to find one exterior angle, again, it has to be regular, meaning it has to be all equal sides because then all the angles are equal. So if I want to know what one exterior angle is, I'm going to take 360 and divide it by the number of sides. So let's see how this works in a real problem. So for number 4, we have a regular polygon has 9 sides. We want to find the measure of the sum of the exterior angles. No work to do here. The sum of the exterior angles of any polygon, no matter how many sides it has, is 360. Now I want to find the measure of the sum of the interior angles. So again, we're going to go back to that 180 times n minus 2. And again, if I'm dealing with a 9-sided figure, that means n will be 9. So I'll have 180 times n minus 9 minus 2. 9 minus 2 is 7. And 180 times 7 should give me an answer of 1,260. We want to find the measure now of one exterior angle. So this is going back to part A. If the sum of all the angles is 360, and again, we have a 9-sided figure. So if I divide that by 9, you're going to get an answer of 40. So one exterior angle, or each of the exterior angles, is going to measure 40. One interior angle, well, if I take the sum of the interior angles from part B and I divide it evenly by the 9 interior angles that they are, I should get an answer there of 140. So each of those angles will be 140. For number 5, we want to find the number of sides of a regular polygon if each exterior angle measures 72 degrees. Okay, so again, what I'm really looking for here, if I know that the sum of the exterior angles is 360, and again, if I divide that by n, it would give me one exterior angle. Basically, I just want to solve this equation. Okay, and very simply, don't forget, if you want to make 72 into a fraction, you can put it over 1, and then you're going to cross multiply. So 72n, 72 times n is 72n, and 360 times 1 is just 360. So to solve this, all you're going to do is divide both sides by 72, and n is going to equal 5. Hey, if each interior angle measures 150, the easiest thing to do, again, it doesn't matter what your shape is. I'm just making a shape here. Let's say this interior angle here is 150. Okay, the easiest thing to do is find the measure of the exterior angle first. Okay, if I want to find the measure of the exterior angle, the interior angle and the exterior angle are supplementary. They have to add up to 180, which would mean the exterior angle would be 30. Okay, so if it's exterior angle is 30, now we're going to go and do what we did in part A. So again, if I take 360 and divide it by n, this time I want my answer to be 30. And same deal, we'll chuck that over 1 and cross multiply. So 30n is going to equal 360. Divide both sides by 30, and n will equal 12. So that figure is going to have 12 sides. Okay, and then for part C, the sum of the interior the sum of the interior angles measures 2,880. Holy, tongue-tied. Okay, so sum of the interior angles, we know what the formula for that is. It's 180 times n minus 2. And now what this question is telling me is if I solve that, I should get an answer of 2,880. So I'm going to set that equal to 2,880. And now we're just going to solve this. We'll distribute 180 through the parentheses. So I'm going to have 180n. 180 times 2 should give me an answer of 360. And that's going to equal 2,880. Next, I'm going to add 360 to both sides. That will leave me with 180n equals 3,240. And finally, we'll divide both sides by 180, and n is going to equal 18. So that means that that figure would have 18 sides. Okay, and the last thing that we're going to answer is how many sides must a figure have in order for the sum of the interior angles to equal the sum of the exterior angles. So I want the sum of the interior angles to equal the sum of the exterior angles. So the sum of your interior angles, that formula is 180 times n minus 2. So that gives me my interior angles. And now I want that to equal the sum of my exterior angles. Well, no matter what your polygon is, the sum of your exterior angles is 360. So all I'm going to do is set those two things equal to each other and solve. So again, we'll distribute our 180 through. So I'm going to have 180n. 180 times 2, again, is going to be 360. Bring down my equals 360. Add 360 to both sides. Those will cancel. And I have 180n is going to equal 720. And finally, to get n by itself, we'll divide both sides by 180. And when you do 720 divided by 180, you should get an answer of 4. So if you have a four-sided figure, the sum of your interior angles is going to equal the sum of your exterior angles. So if you add up the interior angles, think about it. Add up the interior angles of a square. They're all 90. 90 plus 90 plus 90 plus 90 is 360. And the exterior angles, no matter what, doesn't matter what your figure looks like, is always going to be 360. So for them to be equal, it has to be a four-sided figure. And that is it for section 5.1.